So welcome to this video on Reigate College Further Maths Year 2 Core Pure. This is on series and specifically the method of differences. So the idea with the method of differences is that we're going to sum a series, so add up the terms in a series by using some algebra, first of all, to write the terms of the series in a way so that numbers from one term and numbers from the next term cancel each other out. So from one term it's got to be positive, from the next term it's got to be negative. I'm going to switch to the visualizer and we'll look at an example because I think examples are really the way to get to grips with this here. So we're going to start with our example 1 here, and I'll show you how this works. So first of all, we've been asked to show that 4r cubed, we can write it in this form. This is something where really it's going to be more straightforward to take the right-hand side and work back to the left-hand side. So the right-hand side there, I've written it out. That's equal to, or identical to, we should really use an identity sign here, well, we can take out a factor of r squared, and then we can multiply out each of these brackets. So that's r squared plus 2r plus 1. That's that first bracket expanded minus second bracket expanded is going to be r squared minus 2r plus 1. And that is, well, we've got now r squared times r squared minus r squared plus 2r plus 2r. We've got minus there, so it's plus 2r plus 1 minus 1 plus 1 minus 1, which is r squared times 4r. So that is 4r cubed. So we've shown what was needed. We've done it the other way around. So if we look at part B, it says hence prove by the method of differences that the sum of r cubed is equal to a quarter n squared times n plus 1 squared. So what we're going to do here is we're going to say that, well, we're going to write out, we're going to say that the sum from r equals 1 to n of r cubed is equal to, well, we can now use this to say that it's a quarter of the sum of this. So this is the sum of r squared times r plus 1 squared minus r minus 1 squared times r squared. Which is a quarter of, and now we can write out these terms individually. Sorry, I should have put r equals 1 to n on there. So what we're going to do is we're going to consider the first term here. So the first term is with r equals 1. Well, that's going to be, let's put a square bracket here. So the first term with r equals 1, if we put 1 in there, we're going to get 1 squared times 2 squared, which is 4. Minus, put 1 in there, we're going to get 0 squared times 1 squared, which is 0. So that's term r equals 1. Then we're going to say it's plus, let's just put that in brackets as well, term r equals 2, r equals 2. Well, if we put 2 in there, we're going to get 2 squared times 3 squared, which is 4 times 9 is 36. So it's 36 minus, put 2 in there, we're going to get 1 squared times 2 squared, which is 1 squared times 4 is 4. Plus, if we put 3 in here, we're going to get 3 squared, which is 9, times 4 squared, which is 16. 9 times 16 is 144. Minus, put 3 in there, r equals 3. Let's just write it down there. 2 squared times 3 squared, which we already saw was 36. And those terms are going to keep going like that. Then down at the end, if we put in plus, let's have term r equals n minus, what should we go for? Let's go for n minus 2, so that we're going to include the last 3 terms, n minus 2, n minus 1, and n. So n minus 2, if we put r equals n minus 2 in there, we're going to get n minus 2 squared times n minus 2 plus 1 is n minus 1 squared, minus, put n minus 2 in here, we're going to get n minus 3 squared times n minus 2 squared. That's our term with r equals n minus 2, r equals n minus 1, and r equals n are going to come here, so plus, put n minus 1 in here, we're going to get n minus 1 squared times n squared, minus n minus 1 in there, we're going to get n minus 2 squared times n minus 1 squared. That's that term. Plus, put n in here, we're going to get n squared times n plus 1 squared, minus, put it in here, n minus 1 squared times n squared. So, sorry, I've gone a little bit too far there. So we've written out the first 3 terms here of this series by using this expansion, and the last 3 terms. Now let's have a look at what's happened with these terms. So we can see that this one here and this one here are going to cancel, and we're also going to see that, let me find a green pen. I've got a green pen immediately available, which is a problem. Where's another coloured pen? Okay, can't find that pen for now, so never mind. This term and this term are also going to cancel. And I hope you can see that this term 144 would cancel with the next one there. Then going backwards from here, We've got this term here. Let's bring this in red. And this term here are going to cancel each other out. That's positive, that's negative. This term here and this term here. And this term here would cancel with 1 in there. So we're just left with this one and this one. So we're going to say equals minus 0, or a quarter, the whole thing, times that minus 0 there, plus this here, plus n squared, n plus 1 squared. And obviously that's a quarter n squared, n plus 1 squared. Which was what we were aiming to prove. So our sum of r cubed from 1 to n is equal to a quarter n squared, n plus 1 squared. You've already met this formula in year 1, and you've already seen that we can prove that by induction. Well, here's another method of proof for this. Now, this is quite tricky to get hold of to begin with. When you answer exam questions, you do need to be really careful that you lay your work out so it's clear that you do actually have terms that cancel. In general, in exam questions, you're expected to write out the first 3 terms, and at least the last 2. I would suggest, to be safe, write out the last 3 as well. Let's go on to the second question here, which is over the page. Again, I'm going to do this on file paper so that I've got enough space to make my working hopefully clear. So there's a little bit less instruction to this question. Find the sum from r equals 2. Notice that we're not going from r equals 1. Of 1 over r minus 1 using the method of differences. So what we're going to do first of all is we're going to split up 1 over r minus 1 using partial fractions. So we're going to say 1 over r times r minus 1 is equal to a over r plus b over r minus 1. Using partial fractions or method to find a and b, what I would suggest you do is multiply through by both of those terms. So we're going to get 1 is equal to a r minus 1 plus b r. We're going to substitute in r equals 0. So r equals 0 gives 1 equals minus a, so a equals minus 1, and r equals 1 gives 1 equals, this will be 0 now, plus b, so b is equal to 1. Therefore, 1 over r minus 1 is equal to, what is it? B is 1, so it's 1 over r minus 1 minus 1 over r. Now we're in position to use the method of differences on that the series sum. So we can say, so the sum from r equals 2 to n of 1 over r minus 1 is equal to the sum from r equals 2 to n of 1 over r minus 1 minus 1 over r. So we're going to have pairs of terms, and in each pair we're going to have one positive and one negative. So that's equal to, well, let's start off with r equals 2, not r equals 1. I find it quite helpful sometimes just to write what value of r I've got there. So r equals 2, we're going to put in here, this is going to be 1 over 2 minus 1 is 1, so it's going to be 1 minus a half. That's our first term, plus, put r equals 3 in, put 3 in there, that's going to be a half minus a third, minus 1 over 3, plus, put r equals 4 in, we're going to get a third minus a quarter. So we're going to keep going now. And then we're going to get plus, let's put in r equals n minus 2. So we're going to get 1 over n minus 3 minus 1 over n minus 2 plus n minus 1. We're going to have 1 over n minus 2 minus 1 over n minus 1. Let's put brackets around that. Show that they're individual terms, plus, and now we've got n, r equals n, 1 over n minus 1 plus 1, sorry, that should be minus 1 over n. So I've written out now the first three terms and the last three terms of the series. We can see that we've got minus a half there, plus a half, minus a third there, plus a third, minus a quarter there, and I hope you can see that there would be plus a quarter in the next term. Going backwards from here, we've got 1 over n minus 1, minus 1 over n minus 1, 1 over n minus 2, minus 1 over n minus 2. So those terms cancel, those terms cancel, this term cancels with 1 here, and we're just left with the very first and the very last, or the first half of the first term and the last half of the last term. So we can say that this is equal to 1 minus 1 over n, and if we give those a common denominator of n, so multiply this by n over n, we get n minus 1 over n minus 1 over n. Either of these forms would be perfectly acceptable as an answer to the question. So we've now found the sum of the series using the method of differences. I'm going to take that out of the way, and we'll look at the third question here, which looks like that. So this is the parts of this question, and on the whole, exam questions will lead you through like this. Gives you the method. So first of all, we're going to express something in partial fractions form. Hence, we're going to find the sum of the series. It does say hence, so we need to use that. Sometimes you'll have hence or otherwise as an exam question. And then finally, we're going to use that to find a sum to infinity. So for part A, we're going to say 2 over r plus 1, r plus 2 is equal to A over r plus B over r plus 1 plus C over r plus 2. So if we multiply through, we're going to get 2 is equal to A, R plus 1, R plus 2, plus B, R plus 2, plus C, R plus 1. Let's substitute in values for R. So R equals 0 is going to eliminate both these terms. So we're going to get 2 is equal to, put 0 in there, we get 1 times 2 is equal to 2A. So A equals 1. R equals -1. So that term's going to be 0, and so is that term. So we get 2 is equal to, put -1 in there, that's going to be -1 times 1. So that's minus B. So B equals -2. And R equals -2. 2 is equal to, eliminate this term and this term, we're going to get -2 times -1, so that's 2C, so C is also equal to 1. So we can write 2 over R plus 1, R plus 2 in this form. 1 over R minus 2 over R plus 1 plus 1 over R plus 2. So hence find the sum of this series. Well, B, let's write that sum out. R equals 1 to N of 2 over R plus 1, R plus 2 is going to be equal to the sum from R equals 1 to N of 1 over R minus 2 over R plus 1 plus 1 over R plus 2. So this time, each of our terms is going to have 3 parts to it. So let's write this out, write the first 3 and the last 3 terms out. Again, I'm going to do it with each term on a separate line, so it's a little bit clearer what's going on. So let's start with R equals 1. So, and I'm also going to write out the whole fraction, I think, just so it's clear what's going on. So 1 over 1 minus 2 over 2 plus 1 over 3. So that's our first term, plus, put in R equals 2, we're going to have 1 over 2 minus 2 over 3 plus 1 over 4. R equals 3, plus this term, 1 over 3 minus 2 over 4 plus 1 over 5. We're going to have a dot, dot, dot in the middle. Then we're going to use, we're going up to n, so let's have the last 3 terms, n minus 2, R equals n minus 2. So plus 1 n minus 2 plus minus 2 over n minus 1. So that's n minus 2 plus 1 is n minus 1 plus 1 over n plus r equals n minus 1 give myself a little bit more space here. Actually, let's leave that on there. 1 over n minus 1 minus 2 over n plus 1 over n plus 1 plus, and now we've got r equals n, 1 over n minus 2 over n plus 1 plus 1 over n plus 2. Now we've got to look for terms that cancel. And you can see that for each of these terms, we've got 2 positives and 1 negative. If we look at the 1 negative, so we're going to look at the second term for the moment, that minus 2/3 is going to cancel with this plus 1/3 and this plus 1/3. So we've got a cancellation through the middle there. Let's just do that. So these ones are going to cancel. And I think you should be able to see that this one, and another one here would cancel. So there'll be another cancelling there, and this one here. So in each case, we've got a triple that cancels. Let's look down at the last ones here. These ones are going to cancel. This is 1 over n plus another 1 over n minus 2 over n. In a similar way, these will cancel here, these will cancel here. So we're left with 1, 2, 3 terms at the beginning and 1, 2, 3 terms at the end. So we're going to say that this is equal to, well, this is 1 minus 1 plus a half. 1 minus 1 plus a half. I could have left those as 1 over 1 and 2 over 2, of course. And then we've got plus 1 over n plus 1 minus 2 over n plus 1 plus 1 over n plus 2. So the 1 minus 1 cancels, so we've got a half. This is 1 over n plus 1 minus 2 over n plus 1, so this is a half minus 1 over n plus 1 plus 1 over n plus 2. And we're not asked to, but I think in general it's quite good practice to simplify that. So we want a common denominator of, let's make it 2 n plus 1 n plus 2. So 2 n plus 1 n plus 2. What do we need here? Well, we need to multiply top and bottom there by n plus 1 n plus 2. Top and bottom here by 2 n plus 2, so minus 2 n plus 2, and here by 2 n plus 1, so plus 2 n plus 1, which is equal to n squared plus 3n plus 2, minus 2n plus 2n, those cancel, minus 4 plus 2, so that's minus 4 plus 2, that's minus 2 all over 2 n plus 1 n plus 2, which is n squared plus 3n over 2 n plus 1 n plus 2, and that is n plus 3 over 2 n plus 1 n plus 2. Okay, so quite a long question to get to there. Let's just go back to what we've shown. There was what we started with, and we've ended up with that's equal to that expression there. The last part of this, C, was to find the sum of the infinite series. So we're going to say as n tends to infinity, well, n and n plus 3 and n plus 1 and n plus 2 are all going to get very large, and they're almost going to cancel each other out. So this is going to be n plus 3 over 2 n plus 1 n plus 2 is going to get closer and closer to a half. So the answer that we're looking for to that infinite sum, the sum of r equals 1 to infinity of 2 over r plus 1, r plus 2 is equal to a half. Right, so we've been through 3 quite long questions there on method of differences. I hope you've got the idea from that and you can go away and do some practice. These ones with 3 terms in the partial fraction, so 3 terms in each of the terms that you write out, are a little bit more complicated. Start off with some of the ones with just 2 terms within each term in the series. So thank you for listening, and that's it for now.